Hello, this is section 6.7 for Calc survey, and we're going to learn another method to solving integrals or finding the antiderivative. Remember, that means the same thing. So last section we talked about substitution, and hopefully you've practiced that. And now we're going to talk about another method, which is called integration by parts. So I put some examples up here of where substitution is not going to work. So if you find an inside function, like if you let x be u, du is just 1 and you have this extra x out here. So substitution doesn't get you anywhere. So these are just some extra examples of, okay, you've got substitution, and that should always be what you try. You should always try your basic integration rules, then try substitution, and then try integration by parts, right? So real quick, this is a quick derivation. So if you have u times v, and those are two functions that are in terms of x, and I put the d dx in front, which means we're going to do the derivative of what follows. So when you do this derivative, you have to use the product rule. So here's my product rule. First times derivative of the second, and that v turns into dv dx. That's the derivative of v in terms of x. Plus second times derivative of the first. Now here's where you're going to get to see finally why Mrs. Cogswell does this in such a weird way. Because if you now do the integral of all three terms, and notice as I add the integral symbol, I put a dx at the end. Integral with a dx. So as you do the integral of all three terms, now this first one, the dx's end up canceling. You no longer even have an integral. So that's why we just leave uv. I know that's kind of weird notation. But over here, the dx cancels and you end up with the integral of u dv plus, and then again, the dx is canceled, the integral of v du. Now what we end up doing is we move the integral of v du over to the other side. So we now have the integral of u dv equals uv minus the integral of v du. And this is integration by parts. So it's another way to solve an integral. Okay, but it's basically undoing the product rule. Use substitution that we did in the last section undoes the chain rule. Now there's some tips to doing integration by parts. Try to make the more complicated part the dv. Sometimes that works. Let u be the portion of the integrand whose derivative is simpler. So a lot of times the polynomial functions will be the u, but you'll get to see this when we actually do some examples. Okay, so here's our first example. The whole idea is you have to break this up into two parts, a u and a dv. That's the idea. And that's what allows us to use integration by parts. The really nice part, sorry, I keep saying part. The really nice thing is everything that follows that integral symbol has to be assigned to one of these. Substitution's a little bit harder because things can be left in the integral. Like a lot of times we had e to the u or natural log of u and stuff like that. So in this case though, everything has to be broken up into these two parts. So now in this suggestion it said make the more complicated part the dv. So that's what we're going to do here. E to the negative x, let's make that the dv part. And we'll make the easier, and sorry, put a dx there. We'll make this the dv and we'll make just x the u. Now everything that's here has to be what's behind that integral, which it is. That's the left side of the formula that we're doing right now, the integral of u dv. So now we're going to take the derivative of u, which is just 1, and you can put a dx there if you want. And then we're going to do the antiderivative of dv. Now the antiderivative of e to the negative x, e is exactly the same thing, but then you have to divide by that slope. So we'll stick a negative out here in front. So we did the derivative of u, and we did the antiderivative of dv. So by doing the derivative of u, that gives us our du. And by doing the antiderivative of dv, that gives us our v. All right, so now we're ready. So this integral of u dv, that's the left side of the formula, equals uv, So uv is here. So that's negative x e to the negative x, uv, minus the integral of v du. Now that double negative, we'll make that a positive, and we'll make this e to the negative x dx. So that was just a 1. Now you always ask yourself, and this is the most important step right here, did your situation improve? Does your integral look easier now? And that's a definite yes. You no longer have to worry about that x, and you can even do that antiderivative. So let's do that. So we end up with negative x e to the negative x plus, and this antiderivative again is e to the negative x, but then you have to divide by that slope, so we'll have to stick a negative there. And then you just put a plus c and you are done. So we solved that antiderivative using integration by parts. All right, let's try another one. So perfect situation. This is not one of your basic integration rules. It's not a substitution problem. If you tried substitution, you're only going to get back in the same situation you started with. So let's try integration by parts. Here we go. So you're going to assign a u and a dv. Now, we want our u to improve. We want this to be the easier part, and that's, I think, making the negative x your u, and then the cosine of x dx, we'll make that our dv. That's the more complicated part. All right, everything that follows that integral has to be here. That's the only way you can use this trick. All right, so we do the derivative of u, so you get negative 1 dx. And then you do the antiderivative of dv. So sing through your jingle. Sine, cos, sine comes before cosine. So it's sine of x. So derivative of u, that gives you your du. Antiderivative of dv. And then you're ready. We're going to do uv, so negative x sine of x, minus the integral of v du, which turns into, now that negative here, I'm going to make that a positive, sine of x dx. Okay, so here's the important question. Did my integral improve? If it doesn't improve, maybe think back and maybe you assigned the wrong u and dv, or maybe it was actually a substitution problem you should have used. So, but yes, it definitely improves. So I think we're good to go. We can now solve that antiderivative. So negative x sine of x plus, now the antiderivative of sine is sine cos minus cosine. So negative cosine comes first. So negative cosine of x, and I think we're ready, plus c. That's your answer. All right, and remember, you can always go back and do the derivative of this to make sure you get the integrand back. You can always check your answer. All right, now what on earth is this problem doing in this section? You might think, we've done this before. We had to have by now, but you haven't actually. The only time natural log's been in an integral is when you could use substitution. And you don't know how to do this antiderivative yet because you need integration by parts to do it. So we're going to assign a u and a dv. Now remember, everything that follows has to get assigned. So what do we do? Well, you can't make the more complicated part the dv because you don't know the antiderivative of natural log. So we'll have to make natural log of x be the u part. And then all we have left is dx, which is fine. There's technically a 1 there. So everything that follows has been assigned. So now you do the derivative of u, which is 1 over x. You can put the dx if you want. This is just scratch work over here, guys. So if you don't put the dx, that's okay. And then you do the antiderivative of dv, which is x. Remember that 1, that's the slope, so that turns into that linear equation. All right, so then we're ready. uv, so this equals x times natural log of x minus the integral of v du. And the x's end up canceling. All you have left is a dx. Technically, there is a 1 there. But. Now, did your integral improve? Yes, drastically, and it's a lot better now. So then we end up with x times natural log of x minus, and then this antiderivative is x plus c. If you want to memorize that the antiderivative natural log of x is that binomial, that is totally up to you. I don't think you need to, but if you think that would benefit you to memorize that, go for it. Okay. Okay. So let me look through here again. So I did some of these examples. Here's another really good one where I do integration by parts. But now that you've seen a couple examples done, hopefully looking through these makes a little more sense. Now, this problem is an interesting one because you have to do integration by parts twice. But when you do integration by parts the first time, remember I always tell you to ask yourself, did your integral improve? And when you get to this scenario, yes, it did, because now it's just x times e to the 2x instead of x squared e to the 2x. So this is an indicator that you're going in the right direction. There's hope. So you end up having to do integration by parts again. So that's why this gets replaced with another uv minus the integral v du. And then finally you get to where the integral is much nicer and you can actually solve that integral. Okay. Now down here at the bottom, there are a couple problems. This one is one that can be done two ways. You can either use substitution, and here's where you can see why W is not a bad idea, because it gets a little confusing with the U. But you can use substitution, or you can do integration by parts. And I know that the answers don't, well, these don't look too bad, but they are in fact the same answer. But either method would work on this, okay? And there are some times where with integration by parts, when you're doing the antiderivative here, that linear function, whenever there's a linear function, you can do the antiderivative using the power rule. You just have to make sure you divide by the slope. That's a really nice shortcut to keep in mind when you're doing those antiderivatives. And we'll talk about that more in class, right? But if you think through these, this being the substitution part, so the more, what makes this interesting is if you do substitution, so you make the inside your w here, then you do the derivative, you get negative dx. Now, when you go back to look, you realize, uh-oh, I have that extra x out on the outside. But you can take this equation and easily solve for x. Notice you can make it x equals 5 minus w. So when you go to substitute, remember you have to make all of this in terms of w. So, and I had to fix that negative issue, put the negative in front of the x and so forth. So when I go to rewrite it, this x gets replaced with that 5 minus w. And then we put a w in here for the binomial, so it's w to the 1/2, and then we have a dw. So then you have to distribute the w to the 1/2 so that you can actually do the antiderivative of both terms. I mean, it's totally doable, but here's where you might say, ooh, integration by parts is looking a little bit easier. So if you assign a u and a dv, so you make it the easier part, x, dv the more complicated. When you do this antiderivative, this is what I was talking about a minute ago. Add 1 to the exponent, divide by the new exponent, but then here on the inside, that's a linear equation, so you'd still have to divide by the slope. So that's where that negative's coming from. Okay, but now you're ready. uv minus the integral v to u, and then you end up having to repeat that process we just did again. So you have to add 1 to that exponent, divide by the new exponent, but then again, divide by the slope of that linear equation that's on the inside. So yes, definitely more complicated, but I think it's a really good challenge for you guys. And then here's another one where you start off with a substitution problem, make that binomial the w, dw is 2, so we put a 2 and a 1/2 there. And then here's where it's beneficial. If you memorized the antiderivative of natural log, you could use to jump straight to this formula that we just figured out, or you can do integration by parts again. Okay, so it's totally up to you guys. You have got to practice this section, all right? Please, please, please do your homework. We will definitely be practicing this in class. So, and let me know if you have any questions.